Hello guys, good evening everyone. Welcome to Pantech Solutions, and I warmly welcome you for the series A.I Masterclass Day 22. So in this session we are going to start on working on machine learning. I hope a lot of people are interested on learning this machine learning part. So first of all, so we have seen a computer vision and then deep learning and then machine learning, because so actually in artificial intelligence circle, so first will be the machine learning and then deep learning, but it is very interesting to work on deep learning, so that's why we just postponed it, or we just make deep learning first and then machine learning second. Okay, so here in the session going to be theoretical. Okay, like because in the machine learning there are a lot of things which we need to know, like lot of algorithms are there, so that's why we just made this as a theoretical session. Okay, so same as like there is an announcement, so attendance link will be available around 8:30 p.m. so once the session is completed, you just start filling up your attendance form. Okay, so until then don't rush up for the attendance form. Okay, so and then today's agenda, so first of all machine learning and its types, and then the machine learning algorithms, and then finally we're going to have a Q&A session. So here we are going to see very detailed explanation on machine learning algorithm, so please be attentive, so it will be very helpful for like advanced artificial intelligence. Okay, so please be attentive guys. Okay, so first of all, Sunny, good evening. Anupam, good evening, good to see you again. Sharma, Kriti Sharma, good evening. Basha, good evening. Ghosh, good evening. Pratham, good evening guys. The Botex, good evening, good to see you again. Shakti, good evening. Sendil Raghavan, good evening sir. Puvia, good evening. Tejaswini, good evening, good to see you again. Abhishek Ghosh, good evening, good to see you again bro. Lalita Power, good evening. Harsh Gupta, good evening. Logesh, good evening, good to see you again. Kaushika, good evening. Tanush Gupta, good evening. So good evening guys, so we'll go on to the session. So that's it, and there is a little thing I'm going to give for internship participant today. Okay, so that's I just kept like suspense, and another thing I used to say, yesterday I forgot to release, or I forgot to publish the 21st day session. For that, within short span of time, lot of people are commented in the internship while seeing that kind of comment, like sir, you didn't posted the code and then video for 20th day session. So while seeing that kind of comments, I really feel very happy. Like a lot of people are coming back behind me, like they are just following me, like and nowadays I'm getting scared, like if I missed to post something, if I missed to post the code, or if I missed to post that presentation, or if I missed to post video, so a lot of people are ready to post their comments, so I feel really happy guys. So thank you for your your involvement in this course. Okay, so thank you for that. So first of all, while talking about a machine learning, so I hope we have already discussed about artificial intelligence, why we are going for artificial intelligence and everything. So on the artificial intelligence circle, the first circle going to be machine learning, and then only we are going to see a deep learning. Okay, so machine learning going to be one of the part of the deep learning going to be the one of the part of the machine learning. Okay, so while talking about the machine learning, so machine and then learning, so we are going to give our knowledge to a machine. Okay, so for example, if it is for let us take a human being, so human being have lot types of knowledge, so there's not a lot of knowledge, it is lot kind of knowledge. So kind of knowledge in the sense, if it is a recognition based, that is a vision based knowledge. For that we need eyes for visualizing it, and for the brain to recognize it. So vision based knowledge, so first one. So for vision based knowledge only, we have moved on to the deep learning to have better accuracy and to have better feature extraction process. So that's why we had gone into the deep learning. So apart from that vision based learning, so there are other kind of learnings also there. So for example, if someone touches the robot, or kind of if it kind of some kind of weather monitoring system or industry monitoring system, so that may be based on the sensor values, right? So for example, if it is agriculture monitoring system, so it should monitor the soil moisture level and the pesticide level. So a lot of things is there, so based on the sensors, like sensing kind of knowledge. So we have the sensing kind of knowledge, like if I touches the fire, so I'll sense it, right? So that kind of sensor can be directed with the help of sensors for the robot or a machine. Okay, so that kind of sensing can be done, but other than that, to have a better classification or better accuracy to detect that kind of sensors, so we will provide that sensory kind of sensing kind of algorithms. So for that sensing like kind of values, so we'll use the machine learning. So for example, let us take a newborn baby. Okay, so if it is a newborn baby, so if I'm just going to like close my eyes, and if I just move, like if I said like that, so definitely that like baby will get scared and they just start to cry, right? So same thing can also be deployed for machine learning. Like that is nothing but a hearing and vision, right? So hearing and then vision, you can teach it to that kind of baby. Okay, so it will be very helpful. So machine learning is, we are going to give, or we are going to take our knowledge or take our experience to give it to the machine or a computer or a robot in the form of data set. So data set may be varied based on the knowledge. If it is a vision based knowledge, I'll give the data set in the form of images or a video frame. If it is a kind of sensor based learning, I'll give the data in the format of Excel sheet which contains the integer or float values of the sensors. So that's the thing I'll give. And if it is the voice or text based learning, I'll give the data set in the format of text, paragraph, in the format of CSV, but in the format of the sentence or word or text, so which will be given in that format. Okay, so that's all about here that machine learning is. And machine learning is also have the types called supervised, unsupervised, and then reinforcement. I hope you all heard about this supervised and unsupervised and reinforcement learning. Okay, so these details, these learnings are only we are going to see in this session. So like supervised means what, and what are the algorithms which is lies inside that supervised learning, and unsupervised learning, and then reinforcement learning and its example. So like that we are going to learn each and every learning. Okay, so in this session, so this is the hierarchy. I hope I'm just hiding some of the part in this graph. Sorry guys, I can't do anything. Okay, so here, so there is a machine learning here. So machine learning as a core. Okay, so on that machine learning, it already has lot of classifications like clustering, regression, neural networks, ensemble learning, deep learning, dimensional reduction, decision trees, instance based, and then Bayesian. So there are a lot of types in here. Okay, so here a lot of classifications. So on that machine learning, the one of the classification is a deep learning, which we have seen. Okay, so on the deep learning, that RNN, ANN, CNN, DNN, so these things we have seen in the deep learning. So other than that, there are a lot of algorithms, a lot of types, or a lot of segregation on machine learning which we need to learn. Okay, so on that, so for example, if you're taking regression and the clustering, so it may lies in supervised. So clustering, if you take, it may lies in an unsupervised. So likewise, each and every concept which lies in a certain part of the three types of learning, that is supervised, unsupervised, and then reinforcement learning. Okay, so these are the variety concept which going to lies in different parts or different types of our learning process. Okay, so only three things: supervised, unsupervised, and reinforcement. So on this three category only, these and all these functionality or these algorithm going to be lies inside that. Okay, so first of all, while talking about the supervised learning, so supervised learning is very easy, guys. So that is a labeled data. So labeled data, I'll tell you. So let us take our application which we have done before. So or else we'll take let us take a newborn baby again. Okay, so I need to have two folders or two baskets. Okay, so one basket I should have that certain product, like apple means. So if I want to teach a baby called apple versus banana. So if I want to teach that, I need to have one basket full of apple only and another basket full of bananas only. So here it should not be one, not even one banana should be placed in the apple basket, not even one apple should be placed in the banana basket. Okay, so that should be completely isolated. So that is a two folder. Okay, so by talking about AI aspects, so I'm going to have a two folder. So in one folder I'll have like bunch of apple images, and another folder I'll have bunch of banana images, and I'll name the each and every folder as same like that this folder as apple and this folder is a banana. So like that I'll rename it before itself. So I'm going to teach a baby by giving a two separate folder which is a labeled data. So for example, here I'm going to have some of the toy cars. Okay, so just a toy cars. So if I want to teach a baby, so in one folder I'm going to place these three or some kind of bunch of toys in the one folder or one basket. Okay, so on the another basket I'll place pen drives. So for example, I'll have the pen drive. So I'll have bunch of pen drives like 1, 2, 3, 4. Totally this up to this is also look like USB, no? So USB pen drive. So I have a complete number of pen drives here. Okay, so and the another folder I'll have or another basket I'll have the toy cars. Okay, so for the baby or for a machine I want to train like that. So let us take this is a one folder and this is another folder which contains pen drive and this one is a vehicle. Okay, now I need to train like this. Okay, so this is a like a car or vehicle. So like that one by one I'll take and I'll show to the machine to train it. Okay, so baby will observe that and it will try to identify or it will have that experience or that one. Okay, so same as like for a robot or for a machine, this artificial intelligence or for machine learning. So supervised learning is whenever we are giving a data in the labeled format. So before itself we know what the images are and what are the labels are. So that is known as a supervised learning. Okay, I hope you all understand. So if you understand, please type yes in your live chat. Okay, and then while talking about supervised learning in depth, so first of all, supervised learning means, so normally basically we'll segregate into two. One is classification and another one is prediction or regression. Okay, so while talking about a classification, so this classification we have already did. So like for example, we have did image classification and we have did leaf disease detection or classification. So these things we have did, right? So leaf disease, hand gesture, and image classification, Gujarati character recognition. So a lot of things we have discussed in the deep learning thing. So that and all labeled data, right? Before itself in the dataset folder, we kept the folder like if I take leaf disease means anthracnose disease one folder and late blight, dark blight. So like that we'll have different kind of folders which contains a lot of images, right? So that is a labeled data. So that is since it is a labeled data, it is called as a supervised learning. There classification can be done to separate or to segregate the two classes. So here that orange dots are data points and these dots are the data points. So on the data points it's segregated or it's separated that orange as separate class and then blue another as separate class. So same as like a image classification which we done for Thanos and then Joker. Okay, so this is a classification. So classification means it's going to segregate the data which has the similarities or anything. So you're going to segregate into two. Okay, so that's all about the classification. And before itself, we need to give the data set in the format of label. Okay, so a lot of people are telling us it's really great, guys. So classification. Okay, classification. So we are going to classify some of the thing like on a labeled data. Okay, so that's why it's called as a supervised. So on the same supervised learning, there is another concept called prediction or regression. So this is also an advanced topic because now we are doing a real-time classification. That's okay. So that is okay for our like real-time deployment. It's fine. But other than that, if you are taking some kind of application such as windmill or certain machineries or some kind of automobile industry or some kind of robot or some kind of electric vehicle, so a lot of things. So where we require prediction or kind of application. So prediction in the sense, if you are traveling in a vehicle, so on the time, if your artificial intelligence, that is autonomous car now, so if your artificial intelligence can able to predict the damage which going to occur in the engine or ECU, that is electrical control unit, I think so. So if there is any error or if there is any fault going to be happened within 5 minutes or within 10 minutes, so if it wants before itself, so while starting your vehicle itself, you will know. So okay, so within 10 minutes there are going to be some problem in our ECU. So definitely we should not take the vehicle because we're going to stuck it in anywhere or on the road. So that kind of prediction is required, right? On that scenario, we are going to have a two kind of data. Okay, so one is a like variable y and another one is a variable x. Okay, so we are going to predict a y with the help of variable x. Okay, so here variable y means that may be dependent data. Okay, so dependent data with the independent data. Okay, so and this values, so these prediction going to be continuous rather than the discrete. So for example, if you are seeing this graph, so here there are a lot of data points, right? So there are the data points are completely look like a same. So on that y-axis represent the dependent variable and x-axis represent the independent variable. Okay, so here we are going to predict the dependent variable based on the independent. Independent means so it is complete, but it won't depend on anything, right? So for example, let us take a stock, okay, stock predictions or something like that. Okay, so for this up to this year, up to today, I know the independent values. So independent in the sense, what's the today stock and what's the yesterday stock and what is the day before yesterday stocks. So each and every stock value now I know. So that is a independent data. Okay, so now with the help of machine learning, we are going to predict that dependent data. Dependent data in the sense, now I want to predict the tomorrow's or day after tomorrow's stock value. So if I want to predict that, what I require this dependent data. So with this data only I can able to predict the tomorrow's value, right? So there is a dependent data as well as a independent data. We are going to predict the dependent data, which is like upcoming values, with the help of this independent data. Okay, so that's all about prediction and then regression. Okay, so here the data points are there. So that line of regression is the line which going to split it up that part. Okay, so that's all about here. And then classification. So on the classification, so here we have seen two things, right? One is classification and another one is prediction or regression. So on that classification, so there is two things, guys. So first we have seen classification and then regression. So on that, first of all, we'll discuss about the classification. Okay, so on the classification, so there is a kind of like 4 kinds of classification. So on that, first binary classification. Okay, so time for a question. Okay, so we have developed or we have done binary classification in our deep learning. Please specify the project or the agenda or title, anything you can take. So what's the project where we have deployed a binary classification? Please type your answers in the live chat. Okay, so that's it. So first of all, binary classification. So binary classification in the sense, we are going to classify something, but it's going to have only 2 classes. Okay, so that's up to here. Okay, so that's a binary classification. And then second one, multi-class classification. So multi-class classification is, we are going to have multiple classes, okay, but we are going to predict one at a time. So examples such as hand gesture recognition and leaf disease detection. So on the both project, we are trained for multiple classes like hand, trunk, nose or anything, and gesture also 1, 2, 3, 4, 5 and none. So we are trained for multiple classes, but we can able to do for only one class at a time. So that is known as multi-class classification. Okay, answers are there. Who is that? Gray. First answer is Amarnath, I think. Yeah, Aniket also answered properly. That is the image classification, and Amarnath is also right. Joker versus Thanos. And by following Arena, Rollins Arena, it's right. And then Fakim Kamal Ahmed, it's also right. Yeah, it's great, guys, really great. Yeah, so we have deployed that binary classification and multi-class classification also. I have already told that what are the examples. So they are going to be, we are going to train for multiple classes, but we are going to recognize one at a time. And then multi-label classifications. So multi-labels means, so we are going to train it for 2 or more classes. Okay, so 2 or more classes, but we are going to predict both class or both object or both anything at a time. So for example, a real-time object recognition using a deep learning model. So on that also, we have used that retrained model which contains lot of classes. It will also recognize every class at a time, right? It also recognize me as a person, and it also recognize bottle as a bottle, and it also recognize chair as a chair, right? So on that application, that is a main example of multi-label classification. Okay, so and then imbalanced classification. So imbalance means, so the number of example which we are giving us an imbalance. Okay, so let us release the application which we have seen. So first one, right answer, image classification. Okay, and then multi-class classification, hand gesture and then leaf disease. and multi-label classification, object recognition. And for imbalanced, it is not exact one, just for reference I'm telling. Okay, so if you have seen the road sign recognition data set, that data set which we have placed there, it is completely imbalanced. So like first data we have only 200 images, and then second label we may have 2000 images, and then third 1300. So that is imbalance. That is not exact example, guys, just for a reference I'm telling. Okay, so that is these kind of types of classification area. Okay, so and what is the remaining thing? Prediction and then regression, right? So regression. So while talking about a regression, there is a very popular two regressions are there. One is linear and another one is logistic regression. So you are seeing this graph. So linear means so it is completely have one kind of line. So in the logistic there is one kind of wave is there. So I hope you have seen that wave before. Actually that waves looks kind of some kind of function, especially that is actually, I'll release the answer. So that is especially the sigmoid function. Okay, so the first difference is in the linear regression there is no activation function is used. Okay, but while talking about a logistic regression, their activation function is used. Okay, so first of all, while talking about a linear regression, okay, so same as like regression which you have seen before, we are going to predict the dependent variable or value based on the independent variable. Okay, so dependent variable in the sense upcoming or upcoming values. So upcoming, we are going to predict the upcoming value by using the independent values like today's or yesterday's value. Okay, so that's our linear regression. We are going to predict the dependent variable based on the given independent variable. Okay, so we are going to predict the y based on the x value. So x going to be the input, y going to be the output. Okay, so if you are talking about this regression and all, so the ultimate aim or ultimate thing which we are going to do is it's going to generate an equation. Okay, so equation for your application. Okay, and while talking about a logistic regression, okay, it also going to have same kind of classification, but it going to be a discrete set of classes. Okay, so that wave and activation function which we have used there. Okay, so and same as like it has an activation function. Okay, so here this is a logistic. Okay, so logistic in the sense, so here it's going to check either or else, like either spam or not spam, or like online transaction fraud or not fraud. So for example, email spam, so a lot of promotional message is coming, so based on that it will automatically classifying that is a promotional. So it is like it is kind of some kind of repeated message, so we need to drop that message in a spam folder. So that kind of classification, so either or fake news or good news, fake or good, for fake news detection. So those kind of thing can be done with the help of logistic. Okay, so logic in the sense logistic. So that's it. So here the wave, while talking about the graph here, and the value which is present here, it may exceed 0 or it is not necessary to be in range of 0 and 1. Okay, but while talking about a logistic regression, definitely the value which we are going to obtain from the logistic regression output definitely good at 0 and 1. Okay, so that predicted y lies within 0 and 1 range. But while talking about a linear regression, the predicted y can exceed 0 and 1 range. Okay, so that's all about this logistic and linear regression. Okay, so and then linear regression, further it is classified into a lot of types like simple linear regression, univariate linear regression, multiple linear regression, locally weighted linear regression, and also polynomial regression. So polynomial is also one kind of reformed linear regression, and this polynomial is also find like relationship between independent variable and then dependent variable, and for assign nth degree polynomial. Okay, so here it is also finds the non-linear relationship between the value of x and then value of y. Okay, so and then this will be helpful for identifying some kind of predictions like how the growth rate is. So let us take this scenario, this COVID-19. So how the like COVID cost rate is. So for those kind of prediction or those kind of things, so you can use this polynomial regression, like how the symptoms is varying as day pass by. So like that kind of thing or that kind of prediction can be done with the help of polynomial regression. And also softmax regression is also there. On that softmax regression, that is also uses the same kind of, that is one kind of generalized logistic regression, and it's going to handle multiple classes, because before only have two binary, right, 0 or 1. So but if you're taking a softmax, so it's going to have a multiple classification. Okay, so and then SVM. So SVM is also one kind of major application or major algorithm which we'll use. I hope we have used it before, right? So okay, so question. So second question. So we have used this SVM classifier in one application. Please type your answers in your live chat. Okay. So what is the support vector machine where we have used this SVM classifier? Okay. Please type your answer in your live chat. Okay. So if you have seen this image. So there is one set of data points there, that is some kind of pink or purple, and then yellow kind of data sets is there. Okay, so and then if you are seeing that, so intermediate there are some kind of lines which is separating or which is segregating that data points. So that is the hyperplane. Okay, so here this SVM also going to do that. It's going to map or going to plot each and every data points in the space. So on that space, it's going to separate that two kind of classes by having some kind of space or some kind of hyperplane. Okay, it's going to segregate with the help of that. So like that, it will turn or it will expand like this. So the line will be expanded like this. So whenever it touches the certain data point, so it will append or it will move that data point further. So definitely each and every data point going to be segregated, or both classes going to be segregated. So that individual and this one is individual. So like that, this SVM going to plays a role. Okay, so a lot of people are telling answer SVM, image classification, smart attendance system, leaf disease prediction. Why guys, some people are confused a little bit. So yeah, a lot of people have answered the proper thing. So first answer is Amitesh, and then Basha, and then Priyam. Yeah, it's a right answer. So we have used in the attendance system with for that encoding for image classification at the deployment state, right? So we have used that, right? So and then another algorithm, that is a decision tree. So just see the image. So that is a sunny, rain. So sunny, it will check for the humidity. So on the humidity, so definitely if there is more hot, so definitely humidity will be very less, right? So humidity is, if it is high, the answer is no. If humidity is normal, the answer is yes. So we're talking about a wind. So if there is a wind, if there is a rain, so definitely wind going to be very less, right? So weak wind means, so the answer is yes. If it is strong means the answer is no. Okay, so that's the workflow. So like this is also will be helpful. This decision tree will also be helpful for classification and prediction. Okay, so we'll have, which contains the internal node, which contains or which denotes the test on attribute. We're going to test it. Okay, on the terminal, each leaf node which going to have which going to hold that class labels. Okay, so here it is a kind of testing. So here testing going to be deployed, and final this in this leaf nodes, it going to make a decision. Okay, so for example, if there is sunny and then rain, two parts is there. On that, it's going to check the intermediate parameter, that is humidity and then wind. So it will check whether the humidity, whether it is low or high, or normal or high. If it is normal, it is identified that is a humidity. If it is no, definitely it's going to be rain, of course, right? So those kind of level by level checking or a two-step check. So on that time, we'll use the decision tree. Okay, so which is based on lot of parameters. So only to predict the sunny or rain, so there are intermediate parameters such as humidity and then wind. Okay, so for that kind of algorithms or for that kind of application, we will use the decision tree. Okay, so one then we'll take a random forest. So it is little bit similar to here, right? So for example, if you see this part, it has lot of variances. So lot of segregation, lot of things we need to compare it, right? But when compared to this random forest, so this random forest going to be little bit easy while doing a training, because so this is a reframed version. This random forest is the reframed version of this decision tree. For example, it going to combine or it going to connect the decision tree in the parallel format. So in the it going to be the parallel format, so that training will be very better, since the variance or the checking which we are doing was very less when compared to the decision tree. Okay, so this output doesn't depend on one decision. Okay, so for example, so this output doesn't depend on the single decision. So for example, if you see here, this output depends on the single decision. But if you are taking here, this output doesn't depend on a single decision. Instead, it depends on the multiple decision or multiple outputs of the before the process. Okay, so here this is the input and the decision which is making in the first level. So if you see this image, the decision is making in the first level, so it is depending on the single parameter. But here this output doesn't depend on the single parameter, it depends on dt detection, dt and lot of up to dn. So it depends on the lot of detection or lot of output which is getting from the previous process. Okay, so on the final state, the output or which we are obtaining, so that output part which is nothing but the mean of complete output which is obtaining from each and every process, like m1 m2 m3 m4 mn up to n mn. So the mean value which we are obtaining, so that is completely as an output. Okay, so which will be very helpful for training, which has more training like accuracy or kind of thing. Because the variance or the prediction based on a single value, so we have overcome with that kind of problems with the help of this random forest. So tree, so combination of tree is known as a forest, right? So decision tree, so complete decision tree we are going to connect it in a parallel, so that it turned into a random forest. Okay, so that's all about here. Okay, so these are the basic algorithms. So while deploying it in application, we will learn on in depth like syntax and everything at all. So that's all about here. That's supervised learning. Okay, so and then unsupervised learning. So of course it's going to be opposite to the supervised learning. So like unlabeled data. Okay, so let us take a same baby. So I'm going to teach for same this car classification and this kind of pen drive classification. Okay, I'm going to teach that baby car and then pen drive. Okay, so before what we did, so on the like supervised learning, we just kept another basket which contains a car or anything, and another basket which just contain a pen drives, and we have shown one by one object to the baby, like this is the car and this is the pen drive, like that. Now what I'm going to do, I'm going to put it in a single folder. Okay, so single basket or single folder, anything you can take. So if you take a baby basket, if you're taking this ML application in a computer, so that's going to be folder. Okay, now I'm going to completely shuffled in a single folder or single basket. Okay, so which contains every object, which contains both car as well as a pen drive. Okay, now what the machine learning will do, or what this unsupervised learning will do means, so first of all we'll take a one. Okay, like pattern, so pattern recognition. Okay, first of all it will take and it will keep aside. Okay, so that's one kind of object. It doesn't know that is a car, or it doesn't know that is a pen drive. Okay, so because we didn't label it, so it looks different shape. Okay, just keep like this. And again it will take another object and it will look like, okay, so this is also look like same. Okay, we'll keep it in the another basket, and maybe we'll take another object, it's look different, it is not looking like that. Okay, I place this side. So like that it will take one by one. Okay, so this is also look like that only, so we'll place like this side, and then again it will take every object. This is also look like pen drives. Okay, it will take like this. Again it will take another object. Okay, it will look like the first classes which we done, so it will place like that. So like that it will do the segregation. It doesn't bother about the labels, it doesn't know about the pen drive name or a car, vehicle or anything. It just identifying by complete data. It will have that pattern recognition. So it will identify the pattern and it will segregate the data. So another main thing I wish to say is, the example I'm showing here is an image. So don't only think as an image, it may be kind of any data. Okay, so data going to be combined. So on that it's going to identify the pattern and it's going to segregate it. It doesn't bother about the labels at all. So that is known as unlabeled data. So that's why it's called as a unsupervised learning. Okay, so that's it here. Okay, so here and then clustering. Okay, so here the clustering going to play the major role on unsupervised learning. So if you see this image, you can able to understand. So that is kind of grouped one, right? So clustering in the sense, so it's going to segregate, or it's going to form as a group for a set of inputs. So here inputs are this one, right? So its inputs are this one. These are all combination of inputs. Okay, so on that input, it's going to segregate each and every part, and it's going to group this part as a certain folder or a certain part or certain class. And then it's going to take a second part. Okay, second kind of group of object. It's going to group, and it's going to group, or it's going to keep it aside. Okay, so like that it's going to group the similar object or the feature or the data which is similar. So like grouping. So the grouping is known as a clustering. Okay, if you see this image on that data input image, it contains a star diamond, and then circle. Okay, so it's going to segregate and it's going to group separately. So star as a separate group, and then that circle as a separate group, and diamond as a separate group. Okay, so with the help of this clustering, we can able to group of the data. Okay, so this kind of classification is known as unsupervised as well as a clustering. Okay, so on the clustering, so clustering means grouping a data. So on the clustering, there is another main thing which we want to say is K-means clustering. This is also very popular. Okay, and if you are seeing an image, so here that is a first image, 1, 2, 3, 4. The workflow is 1, 2, 3, 4. Okay, so like that only the process going to be happen. Okay, so there is a 4 process. Okay, so on that 4 process, so first one, randomly select the C cluster centers. So for example, so here there is like a kind of part or which contains lot of data points, that is white as well as red data points are there. On the data points, it's going to randomly place a center one coordinate or anything you can take, like C as a center cluster or center cluster. Okay, it's going to place one center at this side, and randomly it's going to put lot of centers there. Okay, so centers for this side and this side, so anything. Okay, it's going to place that center. Okay, so and then on the second process, what it's going to do means it's going to measure the distance between the cluster and center cluster and then data points. So for example, in the second figure, so the triangle represents the center. Okay, and then circle represents the data point. So here we are going to have two classes, so white and then red. Okay, so two clusters, two kinds of class or anything data points. So here it's going to measure the distance between the center, that is cluster center, with the data points and then cluster centers. Okay, so we're going to measure that cluster centers. Okay, so with the help of that cluster or that distance between the two cluster points going to be estimated, and after that, based on that, it's going to attract or it's going to segregate that values, and it's going to assign a new cluster center, so that it can able to identify, okay, so every data is came here or something like that. Okay, so that with the help of this centering process, like putting the center clusters, so it's going to segregate each and every data by identifying the distance between the nearby coordinates or nearby data points. Okay, so here triangle represents the center, let us take. So it will identify the distance between triangle and the circle, like distance. Okay, so and after that it will do the segregation part. Okay, so based on the distance which is nearby. So for example, let us take this centroid or this center cluster. So it will identify the distance between this center cluster and this data point. Definitely it is very far, right? So definitely this is not suitable for this cluster center, but it is near to this center, this red color cluster center. So definitely it will attract here and it will be like appended here. Okay, so the center which is present, or the cluster center which is present in each and every classes, will get that nearby data points to do the same kind of classification or to do the same kind of grouping. Okay, so that's all about this K-means clustering. Okay, so and then reinforcement learning, it is really interesting, guys. Reinforcement learning is the huge learning which is deployed in lot of applications. Okay, so please be attentive. Okay, I hope you are attentive. Okay, if you are attentive, please type yes in your lecture so that I'll check. Okay, so here if you are talking about a reinforcement learning, take a rat in a maze. Okay, so you know about a maze, right? So that is kind of combination of puzzles and everything. So this is the maze. Okay, so on that maze, so on the one end, rat going to be there. On the another end, cheese or tomatoes, or that rat is eating everything. So please keep any object in the other end of the maze. Okay, so first answer is Divya and then Vortex. Really great, guys. Thank you for that. Thank you for your interaction. So maze is there. So on the one end, rat going to be there, and on another end, the food product or anything. Let us take a cheese. Okay, cheese going to be there. Okay, so this rat's destination, or the rat's destiny to reach that reach that cheese to eat it. Okay, so here we have complete puzzles. Okay, so the rat going to observe the environment first. That's the main thing, right? So first of all, it's going to observe the environment. Okay, so some smell is coming from somewhere. So I need that cheese. I need that cheese. Okay, so somehow I need to reach the cheese. So it is completely puzzle. Okay, so first of all, rat start walking, right? Start running. So it will start running and it will look for like any path. Okay, so it will let us take any path. So it will definitely, there will be lot of challenges. So challenges in the sense that road may be blocked. Okay, and rat traps are there. Okay, so that may be rat traps, like I'll place 5 to 6 rat traps. Okay, so it should not go for the rat traps because that rat traps contain some other object other than the cheese, but this rat only like cheese. Okay, let us take cheese in the another end. Okay, so that rat going to want to reach that cheese only. Other than that, it should not trapped in that rat trap, or it should not block in any other blocked route. That's the second. And third, it should not go in the same place. It should not run in the same place. So these are the challenges. Okay, so first of all, what the rat should do? First of all, rat should observe the environment, right? So first of all, observing the environment. So that's the first process. Internal state, that is the maze. So observing the environment. Okay, so observing the environment. After observing the environment, actually observing environmental happening again and again, but other than that, observing environment at initial, and then rat going to do some action like moving forward. Okay, so in moving forward, if it is moving on the proper direction, it will get a reward. So for example, let us take this is a rat. Okay, so let us take this is a rat, this is a like cheese. Okay, so here I am between this rat. Okay, so this is the cheese and this is the rat. So now this rat want to reach this cheese. Okay, now I am the block here. Okay, so now if it collides here, or if it the blocked route, or if it dropped, or if it blocked into rat traps, so that is a loss, right? On the time that reward points will be reduced to 1 point or something like that. Okay, so if it instead, if it turn like this, and if it move forward like this, and if it move forward like this, so for each and every successful movement or successful training towards to reach the cheese, so it will get a reward. Okay, so reward, so reward. So again, if it collides here, so that is a loss of the reward. So for the from the data or from the value which gets a reward, so it will lose a certain point, and until it reaches this cheese, so it will get the reward. So it will be like test and trial. So test and trial. So until it reaches the cheese, so it will do that same process. Okay, so rat will identify, or rat will observe the environment, and it will move, and it may trapped, or it may anything. So it may be trapped, or it may get blocked in the road, but it will learn the lesson. Okay, so that's the main thing, guys, the keyword. It will learn the lesson. I should not go into the trap. And then second thing, so again it will get a reward by overcoming the trap. Again, if there is any trap, it should avoid that, because it gained that knowledge. Okay, it kind of appending that knowledge or learning. Okay, so it will get appended, or the learning will be like continuous. Okay, it won't forget the previous learning until it reaches the cheese. It won't forget the previous issue or previous problem which it faced. Okay, so again it will move on, and it will overcome the failures, or it will overcome the like any kind of blockage or anything until it reaches the cheese. Okay, I hope you understand. Okay, so this is all about reinforcement learning. Okay, so let us take this, say this is the maze. So rat is here, cheese is here. This rat going to want to reach this cheese. So it makes here now this rat is entering in the block road, right? So this is a wrong thing. So instead of that, it should look for, first of all, it will go here. Definitely the blockage road. Again it will come back, and again it will look for any other way. It should not come with the same path. Okay, so that's all about here. Okay, so here this reinforcement learning is classified into positive reinforcement and the negative reinforcement. Okay, and another thing, that output depends on the state of the current input. So here it will be the current input, so and then it will move on, and then that is a upcoming input. So likewise it will have that learning process. Okay, so and then that is a positive and the negative is there. So what is meant by positive and the negative reinforcement learning? If a system or if a machine focus on the performance. Okay, it doesn't bother about the loss or anything. So on the time, it will look for that positive kind of reinforcement learning. It will completely overcome, like it will collide with any other object, like completely it will roll out in each and every place. It will stuck in the trap and it will overcome, and it will again stuck in the trap again overcome. Like that, it will have that lot of, the main focus is on performance wise. So in the positive reinforcement learning, it will have more kind of learning rate or more kind of performance. Okay, but while taking a negative kind of reinforcement learning, that it will have the average performance, but the classification rate or that will be very faster, because it will learn that like for every it will focus on the errors, like these are the main, so these are the traps are there, so like that it will have that learning. So okay, so these are about reinforcement learning. Okay, so and then there is a bonus for internship participants, as like yesterday festive. So I'm going to provide the collection of data set. Okay, so we have already worked on a lot of data sets, so I'm going to give the data sets for you, especially guys, because we have completed the deep learning now. So a lot of things we have discussed, but I wanted you to practice on different applications, like to handle medical images. So those things I need you to guys have practice. So by providing a lot variety of data sets, definitely while practicing, definitely you will build a lot more project other than the agenda, like COVID-19 detection, etc. So on the data set, which also includes COVID-19 medical image, I'm going to provide the data set especially for the internship participants. So for your interaction guys, because a lot of people who are all present in the internship, really they are very focused and they are having that consistency to learn that. I really appreciating you guys. So that's why I'm providing this another bonus. Okay, I'll provide within 2 days. Give me some time. Okay, so definitely I'll give the data sets, so some kind of collections of data sets. So after the session, that after the deep learning agenda, no, so definitely I'm going to give that, I'm going to provide that data set collection. Okay, for sure. Okay, so I hope you like that. So and then again guys, so a lot of people are still in YouTube and they are not practicing. You don't have a code and you don't have the data set, you didn't practice the Python installation, library installation, so you didn't done any assignments. So there are a lot of lacking in knowledge. So while seeing some kind of comments or some kind of questions in my chats, so I can able to identify that and all UT participants. So please, lot of people are UT participants are facing very tiny error they can't able to do, because they didn't know the previous sessions. Like we have to have 30-day sessions, right? So they didn't seen that the first 10-day session, so directly they jumped into 15th day session and 16th day session. Definitely it is useless guys, because we learned by step. So definitely that is useless. While whenever you are jumping directly into the 15th day or 10th day session, completely useless guys. I'm really telling, I'm very serious. Okay, so please go to that previous session videos, learn step by step, so that you will have that knowledge. Okay, so in this today we are having that computer vision, machine learning and the deep learning, as well as a natural language processing, and we are going to have that recorded video for complete 30-day session and complete source code for more than 25 projects, because our plan is for 25 projects, but other than that we are going to provide more projects like COVID-19 detection. I revealed the secret. Okay, so that's it's okay. So COVID-19 detection using deep learning, so the source code, there is a one hint is also there. I'm going to provide it for intern participants, and a PowerPoint presentation of everyday session, because the content which we are giving us is very useful whenever you are deploying your project. If you are proposing this project to your lectures or anything, definitely you need that PowerPoint presentation, that content at all. So that's why we are providing that PowerPoint presentations also, and forum support and flexible timing, because that is like a Udemy. Like whenever you want, you can go through, you can download your source code, you can visualize that video whenever you want. Because this YouTube is night time now, so it's a little bit difficult for some others. So that's why, and YouTube videos which we have done up to now, it's going to be closed as soon as possible. Okay, so and then complete course is 750. It's very cheap guys, so please don't hesitate, because if you are comparing, you just please do compare. I'll give the open challenge, okay, for this artificial intelligence course, and for you, especially UT participants, you just consult with the internship participants. So whatever the artificial intelligence course, they won't provide less than 10,000. Okay, so please have a focus. That's for your learning purpose only. Okay, so please make it serious and make use of this time for this quarantine especially. Okay, this internship portal we will learn .pantech.solutions.net. Okay, and then another advanced news. This is my favorite news this last 5 days actually. It's very easy and it's very impressive. Okay, so letting robots manipulate cables. Okay, so while talking about a robot, okay, like don't see this image, you will get focused, you will distracted. Please give attention to me. Okay, so just for fun, guys. So let us take an object picking a robot. Okay, so it's going to pick a robot like this. Okay, so there is an object, so a lot of machines or a lot of robots are designed to pick up the object like this, right? So for example, object in the sense like let's take a chameleon or something kind of lizards. So that lizards have that tongue, that kind of sticking tongue, so it will stick that tongue with the insect to catch and eat. So that kind of robots also they are building, like same as like a chameleon or lizards. So that kind of tongue. So that kind of robot. Robot. It has grippers or 3 grippers to grip or to capture that object and to pick and to place. Okay, but other than that, to capture this wire or to capture this rope. Okay, so for example, if here, okay, let us take this cable. Okay, so let us take one robotic arm. It should hold this wire and it should put the charger for my mobile. Okay, so here you just observe the challenges. What are the challenges to the robot to should plug it in here? The first challenge is to detect the holes here. So that's up to that one. That is other than that, that is image processing. So I'll leave it. Let us take a robotic part. Okay, so here robot hold like that, hold this wire like this, not like this, right? Not like this, not like this. So there is a pose is there. So how it is holding. Okay, so that is the first one. Pose is there. So how it is posing. So it may pose like this. It may pose like this. So there are different kind of poses there. No, so robots know that knowledge. That artificial intelligence based dumb robots should have that knowledge to hold that wire properly. That is like pose. Okay, so and then is poses enough? Of course not, because I need to give pressure to plug it in my mobile phone. Up to here I don't require any pressure, it is free movement. But while placing like this, I need to apply some pressure, like before here. So here it is very loose in contact, right? So if capture this wire like this, it is very loose, like there is no like hard holding, right? So but when inserting into the mobile phone, so if I hold that in very loose contact, definitely my gripper will move like that, my wire will move like that. On that time I need to wire very firmly and I need to insert in here, so it will be firmed. Okay, so there is a two things, pose and then as well as that force. Okay, so here if you see this diagram or this picture, so that gripper, it contains some white color thermocol, something like that, not thermocol. Okay, so that white color box or white color block is there in the robotic arm. Okay, so on that robotic arm they have G to estimate or to identify like how the pose of the wire which is holding. With the help of artificial intelligence, they are estimating the pose. For example, so let us take this wire and let us take that this is a robotic that gripper. Okay, so they are predicting whether that wire is like this or like this or like this. Okay, so like that, with the help of this pose estimation, so they are predicting how that gripper want to hold that wire. Okay, so either it should hold like this or either it should hold like this, so it is predicting that also. And second one is force estimation, how it should apply the force, either it should hold very firmly or very softly. So like that kind of holding and to handling or to put or to plug in the wire to the mobile phone or to the socket. So to handle the rope or wire with the help of robot, so they are deploying artificial intelligence, especially machine learning, to get the data, to estimate the pose and to estimate the force of gripper, okay, to estimate like how we are holding the wire and in the what position we are holding the wire. So those kind of analysis is done by the robot, in that it is automatically adjusting that wire holding, and it is automatically putting the charge for a mobile. It's really interesting, right? So artificial intelligence is playing very great play in our day-to-day life, right? So we are finally in the end of the session. So it's time to Q&A. Please raise your question, guys. Abhishek Ghosh, internship, believe me, it's very useful, very much useful. Thank you, Abhishek Ghosh. Thank you so much for understanding the importance of the internship. Really, thank you. Sir, in the upcoming session, Anupam is asking the question. Sir, in the upcoming session, we are having a AI snake game. Is it based on reinforcement learning? Really great, Anupam. You are rocking actually. Yeah, of course. Because the snake game is automatically it should identify that what does mean that food or something. So egg, right? So it should eat that egg or something like that. So definitely that's going to be reinforcement learning. It's really great, Anupam. Can show code on webinar on YouTube. We clear code done. I can't purchase. I don't know English show. No problem, because in YouTube I'm showing the code, but that's not enough. Other than that, we are providing some kind of bonus and some kind of information and source code with a PowerPoint presentation. So definitely that internship will be helpful for you. Okay. Can I get help in my own project in internship? I'll give you the suggestion. You may post your 4 questions in the comment box or forum support. So definitely, if possible, I'll try to give the suggestions. Okay, because you are learning the course, right? So that with the if your course is related to this deep learning and then machine learning, definitely I'll give you the suggestion how you can able to deploy and which code you have to use. So based on the application, definitely I'll give the suggestion. I already paid for your internship program. When will I have the access on the program? Sir, definitely will give you the access within 12 hours, sir. So definitely will give you. Sir, please post day 17 code in internship portal. Still is it not day 17? Okay, so definitely I'll update you now, guys. Sure. Thank you for the COVID-19 project. You're welcome. So especially for internship participant, definitely I'll give that. I want to. Okay, definitely I'll give that. But give me some time. Okay, within 2 or 3 days, definitely I'll give that code. Okay. So please upload 17 code. This is missing on the portal. Sorry, Agrawal, right? So sorry. Definitely I'll check now and I'll update you for sure. Okay. Can't install dlib. Dlib.cmake is already installed and path is also added, or still give some weird cmake error. Okay, please post your cmake error screenshot in your internship portal. Okay, for a little bit, that 2 days I just busy with yesterday celebration, so that's why I can't able to handle the forum. So definitely I'll reply you there. Okay, sir, please do a course on reinforcement learning. Okay, so actually guys, this session is planned, like 30 agenda. So apart from it, I can't able to provide, but definitely I'll give as much information I can. Okay, so definitely we are going to provide that advanced artificial intelligence also. So definitely, but this course going to be basic. So if you are not joined in the internship, please join it in the internship. Sir, are you going to use a pre-trained model for COVID-19 project? No, that is one easy hint is there, which you can able to deploy if you are subscribed in internship. You can also do that medical image processing for COVID-19. I'll reveal that secret there. Okay, we'll meet you there. Okay, so that's it. Are you giving codes for machine learning? Yes, of course, but for internship participants. Why? Because on tomorrow onwards, I'm not going to reveal the code that much, because internship participants are there. They need their benefits. Like have that ethic, guys. Like we need to provide for paid users. So that's why we are going to hold that code for YouTube, okay, just for demo. So other than that, you will find everything. Sir, won't find anything about mission vision camera. Okay, so definitely I'll update you, bro, in LinkedIn or anything. So definitely I'll send you that link. Okay. After AI and ML do the reinforcement learning. Actually, the agenda is fixed actually, sir, because further we can't change the agenda. We'll complete the 30 days. So if possible, we'll arrange it for 1 or 3 day session for reinforcement learning. Definitely I'll share. Sir, is it possible to design a course for complete artificial intelligence like class? I didn't get your question, sir. Sir, greatest example for AR and ML, AR plus ML, gamer rooms. That's a great question. Okay, so while talking about augmented reality, so I hope everyone played Pokemon Go, right? So even I played. Okay, I just wander around every street areas of nearby home. So that is augmented reality, like bringing the virtual object into a real environment. Like in Pokemon Go, so whenever the Pokemon is nearby in our Google Map, will open that window for opening the camera. Definitely that Pokemon may stand it in my table or above the bike or above any vehicle. So I'll open the camera and I'll capture that Pokemon with that Pokemon ball, right? So with the help of that is augmented reality, and artificial intelligence is playing a role to develop augmented reality. So for example, that is an Apple Center, So on that Apple Center, they have one table. Okay, so on the table, it will look like only block, like white color blocks will be there. But whenever you are looking at a naked eye, so it will look like only white color blocks or something like that. But there they have placed the AR glasses. If you are wearing that glasses, you can able to see the ultimate plan of Apple's center, Apple Center's ultimate plan of the construction. That's the plan. It's about, I think, 4 years before, I think so. That's a old news, but they have deployed that augmented reality. So it's very interesting. After AI and ML do the reinforcement learning, and I have joined the internship for MATLAB and AI and ML, a regular student in Pantech Solutions, like 30 days course. Most of us interested. Definitely, bro. I'll try to arrange that. Okay, definitely I'll try to do that. Okay. Something about Sophia. Yeah, actually, on the yesterday session itself, we have discussed about the Sophia, the advanced robot, which contains the vision-based ability and learning-based ability. Even that Will Smith is interacted with that Sophia robot. It attains a lot of interviews, and it gave a lot of speeches, and it also gave a lot of funny threats for a human. So we have already discussed about it. Guys, still we are in the Q&A session. My humble request, so don't please rush up for the attendance form. So definitely it will be available in the description. For we are in the 22nd day, guys. So please don't rush up for the attendance while we are in the Q&A session, because a lot of people are really enjoying the session and they are asking for real technical questions. They are asking the questions apart from the this session. So really they are impressing me. Really they are great. So please allow them to ask the technical questions. So don't ask for attendance in the Q&A session. Please, I'm really requesting as a humble. Okay, so please guys. Sir, please search on YouTube till collapse Eminem in the song Machine Operate by Human. What is behind it technology? It's a great question, gamer rooms. Actually, that is based on a genre, right? So genre or artist. So in the Ghana or Spotify, we are filtering, right? So based on A.I. Rahman, so music will be filtered. Based on Eminem, music will be filtered, or songs will be filtered, like Eminem's top 10 songs, and Eminem's best rap songs. So like that, you will have that, you will add that sentence, right? So Eminem is one kind of keyword. So those kind of tokenization, so definitely we'll discuss with it in the NLP. Okay, so that is nothing but a NLP. You will ask about a technology, right? That is NLP. Okay, so NLP will plays a role like segregating each and every word, and it will identify the meaning of each and every word, and it will check the result with the help of machine learning, and it will identify the result and it will display it. Okay, so that's all about that answer. Yep, is that threats possible in future that AI can take over? Yes, of course. We have discussed in the first day itself, like Stephen Hawking's quote and Elon Musk's quote. So everyone is saying, so if you take every technologies, guys, there definitely there will be a different kind of like lot of risk in it. So if you take 5G, so still now we are not experiencing the 4G speed of our internet, but we are moving on to the 5G. There are a lot of radiation problems in the 5G technology, but we are moving. But only thing, whenever we are introducing a new technology, definitely there will be a risk and threats in it, but we need to handle it in a proper manner. That's the main thing. Sir, will you arrange a course in future about augmented reality? Yeah, of course we can. We have the device called Deep Motion. With the help of that, we can visualize my hand. So on camera also we can deploy augmented reality. On the MATLAB masterclass also they have deployed the augmented reality. So definitely I'll try to do that, bro. So before that, we'll have the plan to deploy Raspberry Pi and then Arduino, because now we have learned the software, no? So then we'll move on to the hardware little bit. So after Diwali, I think so. Arduino and then Raspberry Pi. And after that, electrical is also there. Electrical I'm not going to handle, but that Raspberry Pi and Arduino, I think I'm going to take that Arduino and then Raspberry Pi sessions. So and then we'll move on to the first. Till now, a lot of people are asking about attendance. I need top project. Please tell me the project. Please visit pantechsolutions.net. Okay, where you can check it out about the project in different categories, which includes deep learning, machine learning, MATLAB, Python, like other controllers like 8051, PIC, ARM, FPGA, and PINC FPGA, and Raspberry Pi, Jetson Nano. So a lot of categories are there. Please visit pantechsolutions.net. Hello sir, how can I fix PyAuto GUI isn't installed on Python 3.7? Actually, we are using Python 3.7. We have installed PyAuto GUI. Please post your error with a screenshot in the internship portal. Definitely, I'll guide you. Okay. Okay, I think Q&A is little bit over. So please show COVID-19 code. Only output. Only please. Output is in the sense that is kind of medical image. So here I can't show really, guys, so that is completely like out of session, so I can only give that as a bonus. Okay, like COVID-19 detection. Okay, and again guys, so a lot of people are interacting me in you to talk with me through Google Meet and then or Zoom. So definitely I hope you all getting the mail, which includes that link to fill up the Google form. You just please fill up the attendance form. Google form. So definitely they'll shout out and they will arrange one day so that we will talk in a live, like because nowadays it is like you are chatting and I'm replying back in a video, but instead of that we are going to have a video call on a day. Okay, so I hope you like that opportunity. So please fill your that Google form, which will get in your mail. So definitely we'll interact for single person. It may have up to 15 minutes per each person. So I'll try to do that. Okay, so that's one kind of interaction we are going to have. I think that will be very great interactive. Okay, and thank you so much again, guys. So on the tomorrow session, we are going to evaluate and testing that machine learning algorithms. Like we have seen a lot of classifiers today, no? So we're going to evaluate in the program. Okay, so that's all about this session. So thank you so much for this attending the session and for your interaction. I hope you like the session and you understand some kind of concept. So please overcome or please go through the PowerPoint presentation one, so that you'll get that enough idea, like that graphical, that block diagram at all. Okay, and thank you so much, guys. So thank you so much. That's the thing I wish to say. So thank you so much. So it's me, Sanjay. Until then, bye. Okay.